We're going to go briefly over our academic vocabulary. Again, y'all should have learned this in our first lesson, but this is kind of just a recap. So, domain, if you remember, we always talk about functions, x's, y's, inputs, outputs, and now we're throwing a new set of words, and that's domain and range. So, our domain really just means our x's, which are our inputs, right? So we've talked about x's before, we've talked about inputs before. Now we're just adding another word. They mean different things, but they're all very parallel. Those are our x values, our inputs, our domain. And our range is uh, our y's. So the opposite of our x's are our y's, and the opposite of our inputs are outputs, and the opposite of our domain is range. Now, not opposite like two and negative two, just on an ordered pair or any function, it's our input gives us our output, our x's will give us our y's, but we could also do the inverse. Our y's could give us our x's, and our outputs could give us our inputs using inverse operations. Then we talked about discrete and continuous, so always remember, think about discrete as counting. So numbers you want to count. So very things that you can't split up. So like counting uh, talkies, right? So there's one talkie, two talkies, three talkies. There's not someone going to come up to you and be like, hey, could I have 1.1754327 of your talkie? Now they're going to ask, well, how many talkies for this, that, and that? Now, is there another thing, a relationship with talkies? No, but we're just talking about something that's easily countable, something that you would want to count. Where continuous is something that you don't want to count. So think about like a measurement. So something can be as precise as 10 feet, but if you're counting something kind of continuously growing, so think of a tree growing, it doesn't grow in like increments. It's this tall, and then boom, all of a sudden it's this tall. That doesn't happen. That would be more discrete. But continuous is at any moment in time, it is growing. So think of a tree as growing, growing, growing at any amount of time. It's just a very precise measurement. First, I'm going to read it. And while I'm reading it, I want you to think about how we're going to annotate it. Now, obviously, I'm going to annotate it right after, but I want you to remember our cubes method. I want you to think about what you're going to circle, underline, box, eliminate, and obviously solve at the end. Jose has a tub filled with 15 gallons of water. The water is draining at a rate of 0.5 gallons per minute. The function g of x equals 15 minus 0.5x can be used to determine the amount of water remaining after x minutes. What is the range of the function for this situation? And is this scenario continuous or discrete? And how do we know? And then it talks about that they give us a table to put some data points that we know. Well, let's circle some numbers, right? So I see, 15 gallons. I see 0.5 gallons. I see this function. I'm not going to circle the whole function, but obviously, they are numbers, so I guess I will. It looks like a box. I promise you it's a circle. Uh, those are the only numbers that we have. Let's underline the question. So it wants us to find the range. The range, right? Because we could also find domain, but it's asking for the range, so I underlined it twice. And what is this scenario continuous or discrete, and how do we know? Let's box some important words. So, per minute is very important. Draining is very important. And remaining after X minutes. Yeah, I know that's, not, it's a lot, but it's also important to know kind of what we're looking for. So we want to know how many gallons are remaining after each per every minute. It's nothing that we really need to eliminate. And now let's go ahead and solve. So they gave us this little table. Let's go ahead and fill out with the table the information that we know. Well, I know that there's going to be inputs and outputs. So we know inputs, outputs because it tells us it's a function. So we're dealing with some x's, y's, inputs, outputs. So I know my x's are here, and remember our x's are my input. And then I have my y's over here, which are my output. But most importantly, what is my input and what is my output? Well, if I'm looking at my function, I know the variable, this variable right here, or let me put it in a matching thing. This variable right here is my input. And it's a number that we get and we put it into this and we get our output. So this is our output. Well, if we look back at our question of what we circled, we know this word right here is so important, per. That tells us pretty much our variable. So this per is that x and it's attached with the minutes. So we know per minute, this x is talking about minutes. So we know our input is minutes. Now, you didn't have to go through that elaborate way of thinking of that. You can know that determine the amount of water remaining in X minutes. It tells you right there in X minutes. So our input is minutes. Well, they want to know how much water is remaining after X minutes. So after how many minutes, how much water is remaining. So I'm just going to write gallons because that is the measurement we are talking about. And think about that keyword I just said, measurement. So they gave us a function. We didn't have to do anything. They gave it to us. They're letting us be a little bit lazy. They gave us this little function that I underlined and or didn't box, circled, I guess. Um, so let's write that over here. I'm going to make it, you know, g of x. So this function of x equals 15 minus 0.5 times a number. I'm going to keep that blank and not put an x there because I'm going to input minutes out there. So I'm going to start with 0 minutes. Well, if I put 0 in here, because it's an input, 0.5 times 0 is 0. 15 minus 0 is 15. So this is my output right here. So I could actually put, 15 right here, but it's just going to take too much time. But I did it anyways. So there you go. So after 0 minutes, there's 15 gallons still remaining. Well, you can also think about that conceptually. If I'm not draining anything after 0 minutes, if I haven't started the draining process, well, there should still be the same amount of water we started with. And we started with 15 gallons. So at 0 minutes, there should be no water draining at that time. Well, let's put some numbers in here. Let's do 1 next. So I'm going to erase this. This 15 seconds, actually, this 15 minus never is going to change. And remember, it's a constant. It's not going to change. So we really only need to mess with this part of the function. Well, if I put 1 minute in here, or 0.5 times 1 is 0.5, and 15 minus 0.5 is 14.5. So that's my output. So after 1 minute, there's going to be 14.5 gallons remaining. What about 2 minutes? 0.5 times 2 is 1. 15 minus 1 is 14. So we know after 2 minutes, there is going to be 14 gallons remaining. You may already see a pattern popping up, but we're going to put a few more numbers in there. I'm going to do 2 more numbers, and then everyone should know that pattern by now. And then we'll kind of just skip to the end so we could kind of start figuring out our range. So let's put 3 minutes in here. 0.5 times 3 is 1.5. 15 minus 1.5 is 13.5. So I know after 3 minutes I have 13.5 gallons remaining. Let's check 4 minutes out. I'm going to turn this 4 into the 3, being a little lazy, even though I have my eraser. So 0.5 times 4 is 2. 15 minus 2 is 13. And I know I'm kind of going all over the place with my colors, but you're kind of getting it. It's not tricking you too much. So I know a pattern here. I see it. After every 2 minutes, 1 gallon goes away. Well, if I know it takes 2 minutes per 1 gallon, and I know I have 15 gallons, well, if I want to know my last input, Really? I have to just do 15 times 2 because I figured out my pattern, right? I could continue this table forever until I get to 0, or I figured out my pattern. Well, every minute, zero point 0.5 is going away, or after every 2 minutes, 1 gallon's going away. So if it takes 2 gallons per minute, and I have 15 gallons, 15 times 2, remember, per is a multiplication word. 15 times 2 gives me 30. So let me check if my input of 30 will give me 0 gallons. I'm guessing it will, because I think that's the pattern. See what happens. So you have 0.5 times 30. Well, zero point 0.5 is half. Half of 30 is 15. 15 minus 15 is a 0. So, yay, we got all our information here, right? Because I don't want to go negative, right? You can't really have negative, you can't have negative gallons in a tub. It's just going to be 0. With minutes, you also can't have those negative minutes. You can't go back in time and see how much it was. Because if you started at 15, if you went back in time, it's not going to be any higher because you started it at 15. So let's figure out range. And if we remember, range is our y's. So this is a measurement. Um, and I'm already going to answer this question for you because it's going to help us with our range. Uh, we need to know if it's discrete or continuous. As I said so many times, we're doing a measurement here, and we talk about measurements being continuous, right? Because yes, at 1 minute, there is 14.5 gallons remaining, but what about 59.9999873 seconds? How many gallons is there? Remember, it's not discrete. It's not at 1 minute, it's there. The other minute, it's continuously draining. So even at 1.75 minutes, you could put that in the function and you're going to be able to get how many gallons are remaining. Also, if I want to know how many minutes there was 13.33336 gallons, I could put that in the function and I could get it because this is a continuous graph. It's going to be a straight line. So we know with our continuous, we're going to be using inequalities, right? Greater than or equal to, things like that. So I'm going to start with my y because we're dealing with range. What is the biggest number we have? Our biggest number is 15. Can my tub be at 15 gallons? Yes. So this number is included in our answer. So if it's included, that means it could be equal to. Now, if it's the biggest number, we know y has to be less than or equal to 15. Well, what is our lowest number? Our lowest number is 0. We can have 0 gallons in the tub, so our 0 is included in the answer. So we know y is greater than or equal to 0. So we're like, well, that's pretty easy. You're looking at the biggest and the smallest numbers. And we already kind of talked about as to why it's a measurement and not just these concrete whole numbers, counting this, counting that. So since it is so easy to write, even though it's not a question on here, let's take the next minute, pause the video, figure out the domain for this function. All right, so now that you're back and you had that minute to write the domain, we're going to just briefly go over it. So remember, this is our range, our range, and now we're working on domain. Well, we know our domain and our x values. What is our biggest number? So I'm going to write a 30 because it's going to be 30 minutes. It's our biggest number. So again, it's going to be, our answer has to be less than or equal to 30, and it is going to be greater than or equal to 0. Because we can't have less than 0 minutes. We can have greater than 0 minutes, but we can't have greater than 30 minutes because there's no more water left. After all the water's gone, the draining has finished its job. So that's domain. These will be logged for my students. They're going to be in your interactive journal so you can refer to them at any time. Domain and range is a very simple concept. Don't get your mind thinking too much about it. It's as simple as this.